I'm Jasmine Smith. This is Math 1000 Quiz 7 makeup. So the problem given is to find the volume of the solid revolved around first the x-axis and then the line x equals -1. But the part that you're finding is a space bounded by 2 times the square root of x minus 1 and the line x minus 1. So I graphed that here. You have 2 times the square root of x minus 1 here, and then the line x minus 1 here. So to find the limits on this, so the a and b part, for the x-axis part, you're going to use Washer method, which is found by the integral a to b pi times r squared minus r squared, which is big R minus little r, which I'll explain what that is later. So AB, to find A and B, you get the intersections. So this is going to be from 1 to 5. So this is the integral, pi times the integral, I took pi out as the constant, so pi times the integral of 1 to 5. And big R is going to be the line, this line here is 2 times the square root of x minus 1. And this line is x minus 1. So this is going to be big R, and this is going to be little r, given that they're the proximity to the line, to the axis of rotation. So big R is going to be 2 times the square root of x minus 1, and little r is going to be x minus 1. So you square both of these, given by the equation. And so when you square those, you get 4 times the x minus 1, and then you just basically FOILing here, so x squared minus 2x plus 1. You distribute out that negative sign, and you get 4x minus 4 minus x squared plus 2x minus 1. So I combined like terms here, and then I went ahead and integrated. So you get, or actually I did not combine like terms yet. So you still have the pi on the outside that you're multiplying by, and you're still going to integrate from 1 to 5. So I went ahead and integrated, and that's 4x squared over 2. Using just the integration power rule, you add a power and then you subtract by it. So here you just add an x since there was no power here, and then again add a power, subtract, so x cubed minus, divided by 3 plus 2x squared over 2 minus x. And again, this is the integral from 1 to 5. So here is where I divided everything out and put in simple terms, and then I combined like terms, taking it from here to here. So negative x cubed over 3 plus 3x squared minus 5x, and you're going to take it from 1 to 5, so you're going to subtract where you plug in the values for 5 minus the values plugged in for 1. So you're going to get basically, when you solve this and get all the numbers, you're going to get pi times negative 125 over 3, which is what this section equals, or this section, I'm sorry, plus 75 minus 25, which equals plus 50, minus 1/3, which is this section right here, plus 3 minus 5, so which is minus 2. So what you're going to end up with here is 25/3 plus 7/3. All times pi again. The constant comes down from the beginning initial problem, so that's going to give you 32 pi over 3. So that is the first part of the equation, with it being revolved about the x-axis, with the lines bounded by the lines, 2 times the square root of x minus 1 and x minus 1. So down here, I didn't really write everything over again, but I started out. You're finding it as it's being rotated about the line x equals -1. So this is parallel to the y-axis, so you're going to use shell method, okay? Because you have your equations in terms of x. So to avoid confusion, we're going to use shell method because this method allows you to do that. So this is how you set up shell method. So it's the integral a to b of 2 pi times radius times the height dx. So the radius here, because it is x minus 1, is going to be, to find the radius, it's going to be x minus 1, x minus minus 1. So basically x minus -1, okay? So that's going to give you x plus 1, so that's your radius there. And again, I pulled out the 2 pi as my constant. And the height is just, again, the space in between. I graphed it again here. The space in between the graph on top is the 2 times the square root of x minus 1, and then the bottom line is x minus 1. So the height is going to be the distance in between those, so that's going to be 2 times the square root of x minus 1 minus x minus 1. So next, you basically, you expand this and you put it together. So you're going to have 2 pi times the integral of 1 to 5. It's still 1 to 5 because you're still going to use the x values, because the inside is x values. Okay. So when you expand this out, I treated x minus 1 as just a variable, so you're going to get 2x times the square root of x minus 1 plus 2 times the square root of x minus 1 minus x squared plus 1. So honestly, I didn't know how to integrate just this part, so I used my calculator, and that gave you 4 times x minus 1 to the 3 halves times 3x plus 2 over 15. And again, this is all going to be multiplied by 2 pi. So this part I integrated by myself. So you're going to take, I changed this x minus 1, I changed the square root to x minus 1 to the 1/2. And you have to add 1 to that, so you add 2 over 2. So the new power is going to be 3 halves. And again, you divide by that new power. So that simplified will be 4 times x minus 1 to the 3 halves over 3. And then basic power rule here, that's going to be x to the 3rd over 3. And then again, basic power rule plus x. And then you're integrating from 1 to 5. So here you plug in for 5 and you plug in for 1. I didn't have a lot of space, so I did it all here though. I plugged in for 5 for each x, and I plugged in for 1 from each x. And again, all multiplied by 2 pi. So for the values, when you plug everything in for 5, you get 154/15. And when you plug in for 1, what you end up with is 2/3. So 154 over 15 minus 2/3 times pi. And 2 pi times 48/5 equals 96 pi over 5. So that is the final answer for this solid being rotated about x minus equals -1.